Hello everyone, this is Dr. Dhiman and I welcome you all to this physics tutorial series of the class 11 physics. So I am following the book by NCERT for class 11, that is part 1. So in this video we will solve the problem number 2.21 from the chapter number 2. So the problem asks about the precision in a measurement. So let me read this problem first. Precise measurements of physical quantities are a need of science. For example, to ascertain the speed of an aircraft, one must have an accurate method to find its position at closely separated instants of time. This was the actual motivation behind the discovery of radar in World War II. So in the case of World War II, radar was used to locate the aeroplane. So this is one example it is given in this question. Now we are asked to think about some different examples in case of modern science, where the precise measurements of length, time and mass etc. And we have to define the requirement of this precision in this case of these three quantities measurement. Okay. Also wherever you can give a quantitative idea of the precision that is needed. That means we have to mention the order of the precision in this case of measurements. Here we are given with three types of measurement. One is the length, one is the time and another is the mass. Okay. So here we have three basic measurement units. They are length, time and mass. So we will consider one by one. So first of all, let us consider the time. So what is the importance of precision in the measurement of time? Let us understand with one example. Suppose in the distance measurement of the moon from the earth's surface, we can use a laser beam. How we can use a laser beam? Let me show you here. Suppose we have this earth's surface here. This is earth surface. Okay, let me write down here. This is earth surface. Suppose we have the moon here at this location. This is the moon. Okay, now we have to measure the distance of this earth from the moon, or the distance of the moon from the earth. So we have to draw a line to the earth's surface. So this is the distance. Let us suppose this is denoted by capital D. Suppose this much of distance is capital D. Now if we want to measure this distance, we cannot use a meter scale because this is a very large distance. We can use a laser beam to measure this distance. Let me explain you in a very brief method, that is how we can use a laser beam. Suppose we have a laser beam and from here we are transmitting the laser beam. This laser beam will travel through the open space or air and it will be reflected through this moon surface. Okay, and we will receive through a receiver. Okay, that means this laser beam will have a speed of the light, because this is a light. The speed of this laser beam is equal to 3 into 10 to the power 8 this much of meter per second. Why this much of meter per second? Because this laser beam is nothing but it is a light. Okay, so this laser beam will travel twice the distance, because it will go from earth to the moon and then it will be reflected to the earth's surface. Okay, so it will cover the distance capital D 2 times. So here we can write this D is equal to, or twice D is equal to, we will have, this is the speed of the light, that is the c small c, multiplied with the time. That means when we suppose transmit one pulse, laser pulse, it will go to the moon surface and it will be reflected from the moon surface and will receive again in the earth receiver. Okay, receiving station. So this is the time here. Now if we want to find out here, the D, capital D will be c small c into small t divided by 2. The small c has a value of 3 into 10 to the power 8 into small t divided by 2. So this is the mathematics behind this measurement. Okay, so here you can see this value, this t is multiplied with a very large quantity because it is in the order of 10 to the power 8. Now if we have a time, suppose it is 2 seconds, it may be 10 seconds also, it may be 0.1 second also, we do not know. Okay, so this time is highly dependent So this d value is highly dependent on this small t value. So if we make any mistake in measuring the time, a small mistake, that will result in a very large mistake in the case of distance. Okay, so here we can say that this d value is highly dependent on the value of small t, as c is a constant and it has a very large value. C is very large value. Okay, so therefore a small mistake in small t would lead to large error in the distance measurement. So in this case, the time measurement should be precise up to 10 to the power minus 9. Why I am getting 10 to the power minus 9? Because you can see here we have already 3 multiplied with 10 to the power 8, and then we have to again multiply with the small t value. So approximately it is of the order of 10 to the power minus 9 second. So this is the case of the time. Okay, we have seen in the question we are given find out about the time, then mass, then length. Okay, now suppose in the second case we consider the mass of an object. So similarly in the case of suppose atomic or nuclear reaction in the nuclear power plant. Okay, so here also we need precise measurement of mass, and time is also required. This mass and time, these both are required, that means required in this case. So which should be of the order of 10 to the power minus 9 kg as well as 10 to the power minus 9 second. So a small mistake in this value would lead to higher error in the measurement. So here we can write down the order is 10 to the power minus 9 this much of kg in the case of precise measurement of mass, and similarly in the case of time also here we have two variables. Okay, so similarly for time also 10 to the power minus 9 this much of second. Okay, this was the second case for the mass. Now let us consider the third case. In the third case we have the length. Now let us consider the laser therapy. So in the case of suppose the treatment of the tumor in our body, inside our body, so we can consider the laser therapy. So for precise measurement of the position or the location as well as the size of the tumor, so there is the requirement of precise measurement in this case. Okay, and this measurement should be of the order of 10 to the power minus 9 meter. So this precision of this measurement, so let me write down here, this precision of this measurement should be of the order of 10 to the power minus 9 this much of meter. A very small mistake in this measurement can damage the healthy tissues of the body or healthy parts of the body, that is out of focus of this interest. So here I have explained you about the three types, that is the mass, length and time. So thank you for watching. If you have any question, please put it in the comment section below. Also like, share and subscribe to my channel. Thank you.